So now we'll discuss next method of limits, that is the sandwich theorem. Okay, or you can also call this squeeze play theorem, right? So this is also one of the methods to solve, and actually the thing is sometimes we have to use this method. There is no other option. We have to use this method. This is the only option sometimes. Okay, and this is very useful for problems of IIT, because sometimes problems are based on this method only. Okay, so what is the method? Let's say you have a limit, and the limit is limit x tends to a fx, and there is some reason that you cannot find this limit. The reason can be something you cannot solve, some series is given, you cannot solve that series, okay, or you don't have any method to solve that type of problem. Okay, so in that case, if you can think of some function hx which is greater than fx, equality can be there, cannot be there, it depends. Sometimes there is no equality. Okay, so remember that. And there is some function gx which is less than fx. Equality can be there, but this is not must. And then this is not must. This is not must. Okay. And for this point x tends to a, limit of this function is L1. And for this function also, for x tends to a, limit of this function is same, L1. Right? So limit of this function is L1 and limit of this function is L1. Okay? Both the, you can say, bigger function and the smaller function, both have the limit L1 at that point. So the sandwich theorem says, in that case, this limit will be again same, L1. This is the sandwich theorem. Right? We'll discuss how. Why things are like this, why this is happening, we'll discuss that. So to understand this thing properly, we'll see through graph. Let's say our function is fx, will draw. Let's say the graph of this hx is like this, let's say, is like this. At this point a, this point a, limit of this is L1, means this value is L1. This value is L1, y is equal to L1. This is the graph of hx. Now you have one function gx which is less than fx, less than hx, right? Gx, the smaller one. Okay. So gx, value of gx at any point is less than fx, less than hx, means obviously less than hx. Okay. So at any point this is below hx because the value is less than hx. So this gx is, let's say, like this, gx. Okay, here less than hx, like this. This is gx. But at this point the limit is again same, L1. Okay, so at this point the limit is same, so we'll come to close to this point. Okay, like this. We'll come close to this point. Okay, on the right hand limit, left hand limit, the value will be L1, same, because the limit is L1, means limit exists, right? So limit is there, value is L1. So this is gx. Okay, so graph can be like this, gx at any point below hx. Okay, and at this point, limit of gx, limit of hx, both have value L1, right? This is the situation. Okay, now think about this fx. Think about this fx. This fx is less than hx but greater than gx, means this is always above gx. Greater than gx means above gx. Less than hx means below hx. Okay, because the value is smaller. Okay. So at any point, this is in between gx and hx. So fx can be like this. fx can be like this at any point in between these two. Here again can be in between these two, like this. Okay. Now to come to close to this point A, right? Here fx can be like this, Here fx can be like this. But close to this point A, okay, fx has to pass through here, this part, this region in between, right? Because that has to be always in between these two. Right? Okay. So fx will be in between these two, means at this point the limit of fx will be again L1. Okay, same, because it will pass through here on the right hand side also, left hand side also. Okay, it will be in between, right? So limit of fx will be same L1 at this point x equal to a, right? This is the sandwich theorem, because okay, you can say this is sandwiched between these two. Okay, this is squeezed between these two. Okay, a type of sandwich is formed, right, between these hx and gx function. Right. So this is the thing. Things are very simple. You can understand easily, right? But the main problem for such problems is actually when to apply this sandwich theorem. When to apply. Okay. And for that, I am telling you, more than 90% problems, more than 90% times, you can say the limit will be x tends to infinity, one clue. Other clue, more than 90% times, there will be greatest integer function. Like this. You have to solve this limit, let's say. Okay. So right now we cannot solve this limit because we cannot remove this greatest integer function. Okay. So to solve such limit, what we will be doing, we will find one greater function, bigger function, one smaller function, and we will check whether we can find the limit of those two. If they are equal, then the limit of this function will be same as by sandwich theorem. Okay, as by the sandwich theorem. Okay, that will be same. So for this thing, what we will do, we know greatest integer x is less than equal to x and greater than x minus 1. We know this thing. Okay. Now dividing by x. So what we get, x minus 1 by x less than greatest integer x by x less than x by x, that is 1. Okay, right? X by x you can write. So for x tends to infinity, the value is 1 here. And here again for x tends to infinity, the value is infinity by infinity form, a naught by b naught, value is 1. Right? So this means what? By sandwich theorem you can say limit of this thing for x tends to infinity will be again same, that is 1. That will be again same 1. Okay. So the limit of this function is 1. This way you have to apply sandwich theorem. This is the way. Right? We'll see through 1-2 more problems. So now let's say we have another example. We have limit x tends to infinity, greatest integer x plus greatest integer 2x by x. Again, right now we cannot solve this limit because we cannot simply remove this greatest integer function. Once if you can remove, okay, then you can add, you can find the limit. So what we'll do, we have this function. We'll take one bigger function, okay. This will be less than x, this will be less than equal to 2x. So this is bigger function, okay. Now we'll take one smaller function. If I write in place of this, if I write x minus 1, that will be smaller than this value, and in place of this, if I write 2x minus 1, 2x minus 1, okay, then this function will be smaller, divided by x, right? Now we'll check what is happening at infinity. This is 3x by x, so limit is 3 only at infinity. This is 3x minus 2 by x, and for x tends to infinity, the value is a0 by b0, 3 by 1, that is 3. Right, infinity by infinity form, you know this method, our third or fourth method, okay. So this is having limit 3, right? This is also having limit 3. So the limit of this function has to be 3. Right? I think now this is more clear to you. Okay. So in case in books if you find some problem like this, example 3, limit x tends to infinity, greatest integer x plus greatest integer 2x plus greatest integer 3x, so on, by x. Okay, you can use the sandwich theorem like this. You will write one bigger function, you will find that value, you will write one smaller function, you will find the limit, and the limit will be same on both the sides. So here you can use. Okay. Or sometimes you will have some series which you cannot solve using AP or GP, because in series, you know, how do we solve? We use AP or GP, right? Now, the best problem on this sandwich theorem was the problem of IITian 2008 or 9. Okay, that was problem of 2009, I think. Okay, so the problem was this. Fx is increasing function. Right? Limit of f3x by fx for x tends to infinity is 1, and we have to find limit of x tends to infinity f2x by x. This we have to find, right? This we have to find, because now I am telling this is based on, you know, this sandwich theorem, so you can easily solve, but otherwise that was not that easy for the students, and most of the students actually made some mistake, could not solve properly. It could not strike actually that we can solve through sandwich theorem. So how to solve through sandwich theorem, how to find this limit? Okay, how to find this limit? X is tending to infinity means x is positive. X is positive, so x is less than 2x, less than 3x, because x is positive, and fx is an increasing function, so fx is less than f2x, less than f3x. This was the case, right? We have to find this function, the limit of this function. So what we'll do, we'll divide by fx. So divided by fx, divided by fx, divided by fx, right? For x tends to infinity, limit of this was given 1, and you can see whatever x is tending, actually limit of this will be always 1. So limit of this is 1, limit of this is 1, so the limit of this has to be 1, which is in between function, sandwiched between these two, right? So limit of this has to be what? 1, right? So the answer was 1. Okay. Mostly what actually students did was they tried to use an octal, okay, and that way you won't be getting the answer, right? There was no need to use an octal actually. Simply this was based on sandwich theorem. So I think now sandwich theorem is clear to you. Okay, we'll do more problems in next class, right? Okay, bye.